Hi, there's a new initiative within the Bitcoin ecosystem called BITVM. And with that we can create more complex computer programs. And that's enabled by last year's introduction of Taproot. And it's all within the current Bitcoin protocol. We don't need a soft fork or anything like that. So I will present my current understanding of this initiative. So looking at the Bitcoin protocol, the Bitcoin blockchain, it's very stable, it's fully decentralized, it's super secure, but the issue is on the bad side, it's slow. And we need a 10-minute commit to enable a worldwide sync to all these decentralized computers, and therefore we only have a low volume of transaction in a block. We all know about that. The other part is that the blockchain itself has very limited functionality. It's all related to this full decentralization, as we know. But with the start of the implementation of the Taproot, we have the opportunity to create complex signatures. And that's the starting point of the BITVM development. In basic Bitcoin, Alice signs a transaction, so the ownership of Satoshis or Bitcoin is moved from Alice to Bob. But by the introduction of the Taproot in 2022, there's an opportunity to create more complex transactions. So a full tree of signatures can be created. And with a number of inputs, and the result can be OK or not OK. And that's where the trick is coming. This OK or not OK can be compared to the status of a computer bit that can be on or off. So if we compare a computer to a BITVM, we see these logical signatures. A computer is, as we know, just 0, 1. And you can put it on or off. So a bit can be put on or off, but within the Bitcoin protocol, we can use also the same logic. We can sign a transaction, and the sign can be either valid or not valid. And we can use opcodes and create a kind of an OR of a similar machine. So how do we implement? We are at this moment at the bit level. So we need to create programs at machine code level, like we used to do in the early days of computing. So there's a lot to do, but we can create any program at bit level, just like we did with machine code. Then we can create a Bitcoin virtual machine that can run these opcodes. So these opcodes can run within the Bitcoin blockchain, but there's no need. We can just use the same logic outside of the Bitcoin blockchain. And we will only use the main chain if we have conflicts. So we have a big opportunity to decentralize execution of code outside of the Bitcoin blockchain and with more logic. So what do we use? We use something called optimistic rollup. So we change names from Alice to Bob to Paul and Vera because they run program logic together. And Paul is the prover and Vera is the verifier. They both run a similar BITVM instance and with that a BITVM compatible program. So in this case it can be a chess game. There's no need to use the Bitcoin blockchain because everything can be offline. They run the same instance. The only time that we have a debate where Paul and Vera don't agree on the outcome. So Vera can start verify. How does that look? So as stated, Paul is the prover and Vera the verifier. Paul and Vera play chess for Satoshis. They run this BITVM compatible program. They can exchange and sign chess moves, which is part of their program. And at the end of the game, there's a winner. And the winner gets the Satoshis. But what occurs when Paul has cheated? The state of the BITVM machine has all the signatures and the program. So Vera can run a binary compare of her virtual machine with Paul's virtual machine. And when we it's a quick search, of course. We look at which bits are on and off, and we easily get to the point, a small string of bits, where Paul has cheated, a signature that is not correct. The outcome is not what Vera expects. So she can take that part of the program and run that at the main chain. So when the cheating is proved, all the funds move to Vera. So how does it look like compared which state are we at the moment? It's similar as computer programming in the beginning. We have only the zeros and the ones. On top of that, we run machine code to modify the zeros and the ones. We then get to some assembler levels when we started to make a bit of logic, so it's easier to do that. Then we create modules who we can reuse, and on top of that we have the programs until we are now at the artificial intelligence level. But everything in the end comes back to this ones or zeros and the manipulation at that level. So where are we now? We have this signed or not signed. We have a Bitcoin blockchain that can verify everything, and the BITVM. And the next level, of course, is that we need to create some parts of logic that can be reused. So the big thing is we can start using modules that everybody can reuse. And the nice thing is it's open source, and with this we can create full Turing complete logic, which is everything that we can program on any computer we can do using this virtual machine. By starting making small modules, we can go every direction. But the first thing that is checked now is offload computation, like hashing functions that you can do off-chain to get some verification of the blockchain. The hashing functions. Maybe pegging Bitcoin to other coins. We have a lot of things that we create virtual Bitcoins on another chain, and we can start computing there. But we need to peg that to the main chain. Well, we can use the BITVM, so not everything needs to be on the main chain, and it's still verified to the regular blockchain. Of course, we can look at the Bitcoin blockchain and we create logic which is a bit the same as Ethereum does with the Ethereum virtual machine. But there's a big difference. If we look at Ethereum, Ethereum has a bigger environment where everything is executed on the blockchain. With the Bitcoin blockchain, everything will still remain, the basics will still be on the Bitcoin blockchain. Very simple transaction, but on top of that we want complex transactions outside of the blockchain. So we split the parts that Ethereum uses in the virtual machine environment. And of course we have some differences. Where Bitcoin is fully decentralized with very simple machines, Ethereum is less decentralized, because you need to run a Bitcoin machine is very simple. To run the Ethereum machine is rather complex. All the computation is off-chain on the Bitcoin side, is on-chain on the Ethereum side, which means that we have very cheap fees, because only that small transaction that needs to be verified again will be run on the Bitcoin blockchain. And in Ethereum, we use gas prices to pay for the execution on the blockchain, which can be very high, as we've seen at the NFT hypes, for example. Big difference, of course, is that the BITVM side is fully in development. I talked about the chess game, but we're not there at all. We just maybe can move one piece. So there's a lot of development going on, but a lot of energy also within the community. Where at Ethereum, of course, there is mature program using Solidity as a programming language. We're not there at all. So I hope that helps. It's at least my understanding at the moment. If anybody has some comments or where I'm not correct, I will regenerate this video. Hope you enjoyed it. Thank you very much for looking at it.